Hi guys. So next example in applications of a derivative is a stone is dropped into a quiet lake and a waves move in a circles at a speed of 4 centimeter per second. At the instant when the radius of a circular wave is a 10 centimeter, how fast is the enclosed area increasing? Okay, here the question is, first thing is you have to understand the question, then only you can solve the problem. So assume that there is an quiet lake. So in that lake you will just drop it one stone. So in that case the waves will form, that waves which are exactly like a circle. Okay, and the speed of that waves are like a 4 centimeter per second. So in that case, if you consider that a circular wave is of 10 centimeter, then how fast is the enclosed area increases? That we need to find. So for that you can consider area A of a circle with a radius r is nothing but A is equal to pi r square. Then the rate of change of area with respect to time, which is given, that is dA by dt. D by dt of A is nothing but area of a circle, that is pi r square. Now with respect to time t, you have to differentiate, where pi is a constant, r square derivative is a 2r. With respect to time, hence you have to write dr by dt. Is it clear? So now given dr by dt is equal to 4 centimeter per second. So now this is given. The waves move in a circles at the speed of 4 centimeter per second. Hence you can take this is a dr by dt. Now substitute this value in dA by dt, which is equal to 2r pi dr by dt is there. So in a previous step we wrote it dr by dt is nothing but given thing, that is a 4, hence this is 8 pi r, this is dA by dt. But that waves will form like a circle and that circle radius is like 10 centimeter if you consider, then what will be the enclosed area? And it will increases. It is nothing but when the radius is of 10 centimeter, then dA by dt, which is equal to 8 into pi, where radius is a 10, therefore 80 pi, where the unit is nothing but centimeter square per second. So this is what the how fast this area is enclosed is nothing but 80 pi centimeter square per second. Okay, this is what the third problem. So next, the fourth one, and which is important in your main exam. So this they may ask you for a 5 mark also sometimes. The question is, the length x of a rectangle is decreasing at the rate of 3 centimeter per minute and the width y is increasing at the rate of 2 centimeter per minute. When x is equal to 10 centimeter and y is equal to 6 centimeter, find the rates of a change of first one, perimeter of a rectangle, the second one, the area of a rectangle. So here is, as you know that in a rectangle we will have a 2 sides, that is the length and a breadth. So in that length they mentioned that it is a x and a width is nothing but a y. While taking a derivative of such a thing, and if they use a increasing or a decreasing word, then you need to consider the value will be positive when they'll use increasing at the rate. If they'll use decreasing, in that case you have to use negative sign. Is it clear? So now I can write this as, since length of a rectangle is x is decreasing, is nothing but the negative value you need to write, and the width y is increasing, is nothing but the positive you need to write with respect to time it is. Hence we can write with respect to time, with respect to, or rate of change of. If they mention such words in the question, you need to write that as dx by dt. With respect to time, the length of a rectangle will decreases. Decreases means negative sign. Decreases of what? 3 centimeter per minute. 3 centimeter per minute. Similarly, the width of a rectangle will increases, that is dy by dt is equal to 2 centimeter, because I'll write this as a positive. Why? Because it is increasing. Hence dx by dt is minus 3 centimeter per minute. dy by dt is a 2 centimeter per minute. Now first one is perimeter of a rectangle. As you know the formula, perimeter, I'll just consider that as a P of a rectangle is given by, so perimeter P is equal to, which is 2 times length plus breadth. So we need to find, it is a rate of change of. That means you have to differentiate both sides with respect to time. That is dp divided by dt is equal to 2 times. So sum is there, hence you can differentiate both the variables or both the functions separately with respect to time. Therefore dx by dt plus dy by dt. So values which is given, hence dx by dt is a minus 3, dy by dt is a 2, and this is what 2 times of minus 1 minus 2 centimeter per minute. This is what the rate of change of area of a perimeter of a rectangle. So second one, that is the area of a rectangle. So area A of the rectangle, area of a rectangle is length into breadth, where the length is a x variable and a breadth is a y variable. Therefore this is x into y. You have to differentiate this with respect to time. Therefore dA by dt is equal to, two functions are like a product, hence you should go with the product rule. That is, the first function as it is derivative of a second function with respect to time plus derivative of a first function with respect to time, and keep it the y as it is. Now x is nothing but, again the value is given, x is a 10 centimeter, y is a 6 centimeter. So 10 into dy by dt is a 2 plus dx by dt is a minus 3, y is a 6. Is nothing but 20 minus 18, this is of plus 2. I can write this as a centimeter square per minute. Hope you understood why this is centimeter square. Because area of a rectangle is x into y. It is a product. X is also centimeter, y is also centimeter. Centimeter into centimeter is centimeter square per minute. Okay, so this they may ask you for a 5 mark. So I'll just do it the last one in this class. That is fifth one, the total cost, that is the Cx in rupees associated with the production of a x units of an item is given by Cx is equal to it is an equation. Find the marginal cost when 3 units are produced, where by marginal cost we mean the instantaneous rate of change of total cost at any level of the output. We need to find the rate of change of marginal cost with respect to what? Units. That is 3 units. With respect to 3 units, you need to find the marginal cost. Again, is nothing but instantaneously the rate of change of total cost of this unit. Is it clear? So now you can consider that is the cost is nothing but Cx, which is equal to 0.005 x cube minus 0.02 x square plus 30x plus 500. 1000. Now you just differentiate this with respect to what? Output we have to find. So output is what? When 3 units you have to consider. That unit you can take it as a x. So here, which is associated with the production of x units. So with respect to this unit, you have to differentiate this total cost of this. Is nothing but the marginal cost. Now you can differentiate this marginal cost with respect to x is nothing but 0.005 x cube derivative is a 3x square minus 0.02 2x. So 30 x derivative is a 1. Now when unit of the production is of 3 units, then the marginal cost MC is equal to 0.015 is nothing but you just multiply these two and it is replace a x value, or if you get confused, it's write once again 0.04 into x plus 30. This one I just write it one more step, that's it. Now 0.015 x is nothing but 3 square minus 0.04 x is nothing but 3 plus 30. 0.0159 minus 0. Which is 12 plus 30. Multiply this one, 0.135 you will get minus 0.12 plus 30. If you add it together, you will get 30.015. You can write hence the required marginal cost is rupees 30.02 approximately. Hope you guys understood this. It's not such a big thing. They mention it is a C of X is the total cost in rupees, and the production will be a X units, and the item is given by C of X. It is an equation. With the help of that equation, we need to find the marginal cost when the production of the units is a 3, and what will be the amount. So now the required marginal cost is 30.02 rupees. Hope you guys understood this. Okay, we'll solve the remaining problems. This is nothing but exercise 6.1 in the next class. Okay, thank you guys.